Alright guys, let's take a look at understanding some concepts behind level curves. So here's a picture you see, and this represents z equals x squared plus y squared. You have the x-axis, the y-axis, and the surface is above it. Okay. So this is what you do. Let's look at this next picture. So I have here a plane. Now this plane I'm going to label it as follows. Let me lock this. So this is going to be z equals 1. It's that plane right there, like that. Wait, let me move this so you can see it better. Okay, this is z equals 1. When that plane gets intersected with the surface, it makes the circle, the biggest circle that you see there. Likewise with the other circles, that's how they would be formed. You pass planes parallel to the xy plane through the surface. You do that here, you do that down below at the 0.08, 0.06, 0.04, 0.2, and so on. Now on the bottom, you get the projection of that. So this is what I mean. Look, if you take this and you project it down like this, let me do it again. You see, it gives you this. And then you project it, say on this side also to here, you see, and it gives you that. You see that? So then you project this down to here and it gives you this. Then you project this down to here and it gives you that ring and so on. But there's very specific things that are going on here. Okay, so now we're going to understand probably the most tricky thing involved here. Let's look at something here. Let's relate the separation between the level curves that was happening on the surface. So how do we do that? Let me just zoom in here. Okay, to one bit of information. So look, this is a separation from the origin to here. Now look very carefully. Then draw this up to the level curve and draw a slope triangle. Look at that slope triangle. If you were a person and you had to climb here, this is probably not too bad. It's pretty gentle. You can manage that. All right. But now look at this. This other level curve separation distance right there. That's way smaller than this one, isn't it? You see that? Way smaller. Okay, let me push that back a little bit. See, it's way smaller like that. So then you bring it up to here, and then you draw a slope triangle like this. Now, and then complete the slope triangle. If you're a person and you have to now climb over here, for example, this is already harder because it's steeper here. Okay, like that. You can project down to here. Do you see the picture? You see how this is steeper than this? You can compare them. If here, luckily, if I make a copy of, let's say, this red one, so I'll make that red too, and I'll make a copy of this one right here. When you compare these lines, you can tell that the red line is steeper than the blue line. Okay, so let me just maybe move that aside. I want to keep that a bit of tracking on the side here. Okay, so then we go on. Look very carefully again. Just do this in a different color. Look at this separation right here. This separation is a little bit smaller, so you make a copy up to here. Okay, and then you complete that. So draw this leg of the triangle, and then complete the slope triangle. So then you place this relative to the other ones, you see? The green one is now steeper than the red one, just steeper than the blue one. So in other words, this is like saying here would be the most this would be more difficult to climb than relative to the other two, like that. And again, if you want, you can draw this line here to make sure the projection is correct there. Okay, now let's go on. So now let's maybe do this one, whatever, in some color. Okay, let's take black one here, okay? So then I make a copy of it here. Look, up to here. Okay, and then you complete the slope triangle like that, and then like this. Okay, now it looks like the green and the black are almost the same, but make a copy and place it relative to here. And you see, the black one is actually steeper than the green one, which is steeper than the red one, which is steeper than the blue one. So again, here it would be even more difficult to climb. You can tell just by looking at this, it would be very difficult to climb. It's very steep. So what is it telling us? It's telling us that this separation here, this separation right here, that is relevant in the sense that it tells us the steepness of the surface. Something very important to understand during this entire process. You really have to understand this. The vertical separation is always the same, so look very carefully. If I make a copy here and I put it here, you see it's the same thing one more time. Look carefully. Look at that vertical separation. I just made a copy of the segment. If I put it here, it's that. It's the same thing. If I put it here, it's the same thing. If I put it here, it's the same thing. It's always the same vertical distance you're climbing. But because here you're doing that over this much larger horizontal distance, the slope is gentle. At the very end, you're doing the same vertical distance. You're doing it over a shorter horizontal distance. Therefore, the slope is bigger here. It's steeper. And that reveals itself in this distance right here between the level curves. Short little bit longer, and then the longest. In other words, most gentle slope to the least gentle slope, or the steepest here. So that's how you think about these. If you like, you can also, let me show you quickly. I'll just bring these triangles in here. Look at the construction here. Okay, so that looks like this. And then you see, I can just copy this directly. It's about the same for all of them, but with the, obviously, you see it's about the same for all of them. When you compare the slope triangles, you see that? So clearly the black one then is the steepest relative to this one here. And the black one is steeper than the intermediate red and green ones. Let me zoom out. Leave a like if it's helpful.